Hi guys, in this video I'll cover arrays. Let's first go over array basics. An array is a collection of elements that are stored in consecutive memory locations. That means the elements of an array are stored right next to each other in memory. The size of an array cannot be changed. That means after the array has been initialized, its size is fixed. And every element in an array is of the same type. If the array stores pointers, the pointers can point to objects of a subclass type using polymorphism. An index, also named a subscript, is used to access an element in an array. The index is really an offset, so it starts at 0 and ends at length -1. It's an offset based on the starting address of the array. The starting address is also the address of the very first element of an array. So an index of 0 would stay at the starting address or at the first element of an array, while an index of 1 would be one element further from the starting address. Here you can see an example of an array. I have an identifier named values. Values stores the address of the first element of the array, which is 8. And this array has a size of 5, so the indices start at 0 and end at 4. Note that you never access an array at its size. So you never want to access this array at index 5, which would go beyond the bounds of this array. Here you can see what the code looks like for creating this array. First, I specify the element type, which is an int, followed by an identifier, and then in square brackets, I specify the size. Then I use assignment statements to assign values to each of these elements. First, for values at index 0, I assign 8. This places the 8 as the first element of the array. Then values at index 1, I assign 4. This assigns 4 as the second element. And then values at index 4, I specify 53. This places the 53 as the last element of the array. There's another syntax where I can create this array in a single statement. Here I type int followed by the identifier, which I use values, and then in square brackets I do not specify the size. The size is then inferred by the initializer list. I use 8, 4, 12, 29, 53. These are 5 integers, so this will create an array of 5 integers with these values, just like you see up here. You can also specify a size here, but be sure that the size you specify is large enough to accommodate all the values in this list. If the size that you specify here is larger than the values in the list, the remaining values will be initialized to 0. Another way of creating an array is using dynamic memory allocation. Here I use a pointer to an int. I use the same identifier as in previous slides, named values. This then stores the address of the very first element. And then I use the new operator to allocate memory for 5 integers. The new operator returns the address of the first element, and this address is then stored in values. Note that whenever you use the new operator, you have to manage the memory yourself. That means you have to use the delete operator to free up memory. Because this is an array, I have to use delete square brackets followed by values. Note that I do not need to specify the number of elements in the square brackets that follow the delete operator. Note that there are 2 different ways to specify the syntax for accessing elements. The one you've seen so far is using the square brackets, also named array syntax. This simply uses the identifier, and then in square brackets you specify the index, and then you can read the value stored at that index, or you can assign a new value to that index on the array. It's also possible to use pointer syntax. So here I use the dereference operator to go to the address stored in values. This goes to the starting address of the array, which is 8, and here I assign 8 to it. So this places the 8 again as the first element of the array. I can also use the offset the index to add to the starting address. So this simply uses the starting address plus one element further. So it's the starting address of 8, and one element further gives me the second element in the array. And then I use the dereference operator to go to that location. So it's go to the address plus 1 and then assign 4 to it. To summarize, here you can see again the 3 ways of initializing arrays. The first one creates an array of 5 integers. Note it's a good habit to not use a literal here, but to use a constant instead. So you can refer back to the constant in your code whenever you need to know the size of an array. The second one creates an array of scores. The size is inferred by this list, and these are the initial values in the array. The last line again uses dynamic memory allocation. I specify a pointer, I declare a pointer, and then initialize it to new int of 5. The examples below use a class named pet. So the first line creates an array of 5 pet objects. The second one uses an initializer list, and I call the default constructor. So it creates 3 objects and then places the 3 objects in an array of 3 pets. The next one is an array of 5 pet pointers. And then I use a list to call the default constructor with the new operator. So this creates new objects and returns the address of that object in memory. The last one uses dynamic memory allocation. So it's again an array of 5 objects. This does not store pointer, so don't get confused by the pointer here. This is a single pointer to the starting address, while this is an array of pointers to pet objects. Here again is an example of how to declare initialize, how to read the first element, and how to read the last element. So this is a good habit to do, using a constant integer for the size, specifying the size, and then declaring the object of size integers, and here I specify and initialize the elements to these values. Here you can see how I get the first element using the identifier followed by square brackets and 0, and how I get the last element using the constant that I declared above. So it will be always size minus 1. Don't fall in the trap of just using size. Remember, the index always starts at 0 and ends at size minus 1. This shows you how to loop over an array. So it's the same array as in the previous slide. This is an array named numbers. And then I simply output the string index equal element. Then I use a for loop starting at I equal to 0. The index starts at 0. I less than size. Again, make sure you use less than, not less than or equal to. And then I increment the index in each iteration. And then I have a cout statement. I output the index followed by an equal sign, and then the element stored at that index. And then I add a line break. Now, what is the performance of an array? Getting and setting a value is just using the identifier followed by an index, so we can compute the address directly and jump to that address. It is O1. Adding an element or inserting an element is ON. This assumes that you have to search for the element first. So assume an array like this. Let's say it has a size of 5 and I have 3 elements stored: 33, 28, and 5. Now to find the next available position, which I specify as 0, I would have to go over the array and search for it. That's where ON comes in. If I keep track of the index, I can optimize it to O1. Then inserting a value is ON. So if I want to insert a value, let's say between 33 and 28, I would have to use position 28, place the value here, and then shift all subsequent values over by 1. So 5 would go where 0 is, 28 would go where 5 is now, and then I can store the new value. So in the worst case here, I would update the very first element of the array, and the entire array would have to shift over by 1. Delete is the same. If I would delete an element and I don't want to have empty elements left in the array, I would have to shift everything over to the left by 1. So if I were to delete 33, I would have to shift 28 over to the left by 1 and 5 over to where the 28 is. Then contains. If I want to check if a value is contained in the array, I would have to iterate over the entire array and compare each element in the array to the target element that I'm searching for. So worst case, I don't find it and I search through the entire array, which would be ON. Then to get the size or the capacity of the array, I can simply use the size constant, it's O1. To get the number of elements in an array, again, I would have to go through and count. Assuming 0 as the default value, I would not count these, so this would have a size of 3 and a capacity of 5. To recap, what are the advantages? There's very efficient storage for an array. We get fast random access using the index as an offset, but there are also limitations. We have a fixed size. The array cannot be resized after it's been initialized. There's a good potential for wasted memory if the array is not full. Say we create an array of 50 elements, but we only use 4. And then we have a lot of memory that is allocated, but we don't use it. And if we want to avoid null values or default values in an array, we have to shift elements doing insert and delete operations. I hope you enjoyed this video. Thank you for watching.